Just to warn everyone, I'm really suspicious of technology today. So welcome, I hope, to the Weekly Space Hangout. I'm Fraser Cain, publisher of Universe Today, and I have organized a group of space journalists to join me today. So we have got Alessondra Springmann, who is muted.
Hi! I'm not muted anymore.
Whoa, that was really
Technology
smooth.
works for me.
That was so professional. I was like, she's totally muted. This is no. Oh, we've got Dr. Brian Koberlein.
Hi, I cannot be muted.
You cannot be. We got Dave Dickinson.
I know some people like that.
Hey, still camping out here in Florida.
Nice, in your own house.
Camping out in our house.
Yeah, so rugged. We've got Jolene Creighton for her second appearance here on the Weekly Space Hangout.
Yes, good to be here again for the second time.
Nice.
Yes.
Now, but that's it. You know, the gloves are off this week, Jolene. You know, last week we gave you your shot to be the rookie. This time, yeah.
Okay, so now if I crash and burn, it's all on me. No excuse.
Yeah, exactly. No excuses. And we got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser. This is the largest group we've had in a long time.
I know, and strangely we actually don't have a guest this week, which actually feels all right. You know, feels like we're gonna have enough time to talk about all the space news stories. So, let's get cracking. But before we do, I just want to remind everybody that this is an interactive experience. We're going to talk at you, but you can also talk back to us. And so the way you can do that is if you're watching this somewhere on YouTube or wherever, there's a link at the bottom that says that we're interacting live with the audience. Click that, and then you'll be brought into another interface. You'll still be able to watch the video, but you'll also have a place where you can post any questions or comments that you might have. And just to prove that this is a real thing and real people are actually watching, I'm going to say hi to Ben Kalo, William Hutchings, Nancy Graziano, Jason Carlson, Tom Nathy, Yov Landsman, Richard Clark, Gazelle Sabarin, Tony Lynch, Tom Van Scotter, Bert Walters, Matt Woods, Ignatiy Romanov Cherengovsky. Can we have a smaller, shorter version of your name? And Lionel Ward. So, hey, everybody, for watching the Weekly Space Hangout. Thank you so much. Hit us with your questions, and we will try to incorporate them into the show. All right, so we've got a pile of stuff to talk about this week, which is great. And I think where I'd like to start is get some kind of update on what's happening with Ceres and those white spots. So Morgan, you've been following the story, right?
That's right. So we've been tracking Dawn's approach to Ceres over the last few months. Dawn, of course, is the spaceship that recently was in orbit about the asteroid Vesta, and then left last year, Vesta, and began its journey to Ceres. It's now entered orbit around Ceres and has been slowly sort of circling closer and closer to Ceres. And for several months now, images taken by both the navigational and the science cameras for Ceres have shown a pair of very striking white spots that seem to be embedded within one of the craters on the surface of Ceres. And as we've gotten closer and closer, we've been able to see more and more detail. Originally it looked like just one white spot, and then it clearly split into two, and then as we've gotten closer, we've been able to see those two spots more distinctly. And now, with even better imaging and even better resolution, we're able to see that it's not just two spots, but a whole number of spots. And I have an image here, or a series of images, taken with Dawn's cameras here. Let's see if I can share this. There's me. And hopefully this is a series of images taken by Dawn. And you can see as you move left to right and then down the rows that it's more than just two undistinct white spots now. You can actually start to see some detail. They look like sort of uneven splotches hiding within this crater. And people have counted more than two. So I think I've even seen as many as 10 distinct spots have been counted in images now within this crater. And it's important.
Yeah, on that middle row, there's clearly like three little dots on the beside the right-hand one. I don't know if people can see that in the resolution of what they're seeing, and they're maintaining that position as Dawn is orbiting past.
Right, and it's important to stress here that what's happening is not that new white spots are forming. It's possible that that is happening, but that's not what we're seeing here. What we're seeing is basically just more and more detail in the same area, and that's allowing us to see more clearly that we're looking at a bunch of distinct objects, not just a single one. It's like looking at a very far away object and then walking towards it and realizing that what you're really seeing are 2 or 3 or 4 different objects. And the closer that Dawn gets to Ceres, the easier it'll be able to distinguish between these different spots on the surface. But even at this level, there's enough detail here for the principal investigator of Dawn to conclude that these spots are affixed to the surface of Ceres within this crater. And that is in a little bit of contradiction with some of those results that leaked out of the Lunar and Planetary Science Conference about a month ago that suggested that some of this was being detected even when the spacecraft was looking edge on, and people interpreted that as plume activity. And here what we're hearing is that the spots that we see from this angle correspond to things that are located on the surface. That doesn't mean that there aren't plumes, say, within those spots that are shooting up and then falling back down to the surface and causing ice to form on the surface. But the splotches we see here are not the tops of plumes. According to the science team on Dawn, we're seeing ice located on the surface of Ceres.
So, I mean, they look like crazy alien lasers pointing at us. So I think it's important for people to understand that there is a contrast boost that's gone on in these images.
Right, that's absolutely true. Imaging things in space is extremely difficult because there's not a lot of light, especially when you get out beyond Earth and Mars, where you'd find Ceres, and things tend to be very dark. And so the surface of Ceres is very dark. It's like many objects in the asteroid belt are darker than pavement that you drive your car on. And we're looking at them from a long way away without a ton of illumination there, and so they have to really jack up the contrast. And what that means is when something is actually genuinely bright, then it just blows out and becomes so bright that you can't see any detail into it. And so once they start getting closer and the white spots take up more and more of the field of the image, they'll be able to better adjust for those particular features. Until then, they're stuck trying to resolve, and their goal here at this early stage is to image the moon or the dwarf planet itself, because they need that for navigational purposes, for planning the rest of the mission purposes. When they want to focus in on these white spots, they'll be able to do so in a way that better shows their brightness.
So rotation I put up here, this is a movie that NASA JPL just put out a few days ago that you can see the white spots moving across. And like we were talking about before the show, Morgan, there seems to be an idea out there that these spots are somehow multiplying. I don't know if you want to speak to that at all, about why we're seeing more of them now.
Right, yeah. So they're not actually multiplying. It's just that before we were so far away that we couldn't distinguish one from the other, and they blended together into this large blob, which is why we originally saw one, and then we saw two, and now we see 3 or 4 or 5. There all 5 or 10 or however many there are have always physically been there. It's just, you can imagine your camera is made up of a lot of little buckets that collect light. And if 2 of those spots happen to send their light into the same bucket because the buckets are covering so much of the crater, then it's always going to show up as one spot, even if there were 2. And there could be 1,000 spots down there, but if we're so far away that all 1,000 spots send their light into the same little bucket on our light detector, then it shows up as 1. And the closer we get, the more buckets we get over top of this area, and the more we can see the individual features.
So
but
they're not
what are they?
They're not monoliths that are like multiplying or anything.
Right,
No,
I mean,
no.
Aliens.
Aliens.
I'm
I'm
saying
saying
they're
it's
aliens. But aliens.
Like the thing on Mars that was, a big face for years and years, except then we actually got imaging capabilities and discovered, no, it's not even remotely anything like a face. It's really just, it's a big rock, essentially. That's what it is.
Right, and shadows can also, that was a big thing with the face on Mars, is the shadows at different levels sort of act in different ways, and that can mislead you into thinking one thing when it's really something else.
So what is it?
So I would say all bets are that we're looking at ice on the surface of Ceres, and if you combine this with the leaked results about possible plumes extending out from the crater, what we're seeing probably are plumes or geysers that shoot up out of the surface of Ceres. Most of that material falls back down because it's very cold, so it's not building up a lot of pressure, and so it's not going to shoot out with a lot of velocity. And it falls back down to the floor of the crater where it solidifies down into ice. And over time, this process builds up the sort of uneven splotches that we see on the surface.
It's ice. That is super boring.
Solar system can be a boring place sometimes.
Boring. I mean, there's more water in other places in the solar system. Come on, dude.
All right, fine. All right, well, you know what? Let's move on. We've got we got a million stories to do, so let's move on. So we're going to do a round of interesting new ideas for spacecraft. So let's start, Sonda. You've got a mission about a plane going to Venus.
Yeah.
And I'll get a picture here for you.
All right, so Fraser's going to get us a photo. So every so many years, NASA has a call for mission concepts, and there's a couple of different classes. Some cost about $500 million, some cost $1 billion, and so the $1 billion category is called New Frontiers, and I think New Horizons is one of those, and OSIRIS-REx is one of those missions. And so this latest idea is an inflatable Venus mission, which is an inflatable space plane that's propeller-powered, and it's called VAMP, which is a Venus Atmospheric Maneuverable Platform. And so it has two propellers that are going to cruise in Venus' atmosphere and study this really super nasty, acidic atmosphere. So this would fly about 50 kilometers above the surface of Venus and study its clouds and other things. So this is this kind of wild concept. People are building lightweight prototype wings. So this was a lot of the technology is coming from canceled DARPA projects, which I think is kind of interesting. And the military contractors involved with this. Northrop Grumman hasn't done a lot of planetary missions lately, so it's sort of interesting to see them get back in the planetary game. So
I mean, a lot of people don't realize just how surprisingly normal the high altitude of Venus is, right? That, you get up above 50 kilometers and the temperature and the pressure is the same as we have here on Earth. That you could literally stand outside, some dirigible in the high altitude of Venus and watch your skin dissolve from the sulfuric acid, but at least you could be standing out there with like shorts and a t-shirt.
Right, and if you wanted to survive on the surface, that's just not feasible. But if you're trying to be at 50 kilometers or 70 kilometers above the Venus surface, then it'd just be like at 1 atmosphere on Earth, except you'd sort of have you'd be like having sulfuric acid sprinkled all over you.
Yeah.
So it's not so bad. Some of the challenges aside here are that some of the technologies aren't really ready. There's this concept, this technology readiness level, this TRL level, which when I hear it, I think Total Request Live, but that's just when I grew up. And so that a lot of these technologies aren't quite ready, but they're hoping by the time that this mission would get selected that they would be ready. So these inflatable wings and some of the cameras, but it could be this is a really great opportunity to study Venus's atmosphere. And we've known since the 60s that Venus has had this runaway greenhouse effect, and that's something that could happen here on Earth. So by studying Venus, we can probably understand some of the processes that might happen here on Earth. So that would be pretty cool.
And more importantly, we could figure out what it would take to build our sky city on Venus.
Yeah, exactly. I know we have a lot of Star Wars fans who watch, and Cloud City, we really want a Cloud City on Venus. So this could be the first step into having a Star Wars Cloud City on Venus, which would be pretty cool.
Jolene, you've got a different mission concept, in this case going to, Phobos?
Yes. So in case anyone doesn't know, Phobos is one of Mars' tiny moons. It has 2 moons, Deimos and Phobos. Phobos, it's only about 20 kilometers in diameter, pretty small. But this mission essentially is a Phobos first mission. So the ultimate goal is to get us to Mars sometime in the 2030s. NASA's looking at a bunch of different proposals in order to make that possible. And so they just came out with this, it's called a Phobos first mission. And essentially the idea here is that we'd use technology that's already being produced by NASA. So for example, there is the Orion crew capsule, which I think is supposed to be ready for launch to the ISS for resupply missions, testing and stuff like that around 2018. And then they hope to have it ready for manned missions by 2021. And so the Orion crew capsule, it's meant to take people to the ISS and also to assist with deeper space missions, and ultimately the idea that they have in mind is Mars. But there's a number of advantages to stopping off at Phobos along the trek. It's just a lot easier to get there and work than it is Mars. And so one of the reasons is Phobos doesn't have an atmosphere because it's so small. They don't have an atmosphere to contend with. So you start to think about, well, what's difficult when we're thinking about getting into planets? Well, going through that atmosphere and all the fire and the heat shields that you need because of the atmosphere, you don't have to deal with any of that on Phobos. Also, because it's so small, and it's relative location to Mars, you have pretty much a constant view of the surface of the planet. So it's really good to set up some people there, some bases there, as sort of a jumping off point. So you can observe the surface. It's also a lot easier to put material in orbit around Mars and retrieve it than try and get the resupply and all that stuff down to Mars. So.
Isn't it the site, though, of a horrible video game where they dug too deep, and is that where Doom was set? I think.
I think I might have to surrender my geek card because I've never read or seen Doom, so I can't do that. I know.
Literally hand it over right now.
I know. I do have a Star Trek tattoo, though, so I feel like that should maybe bring back.
Right, you can flash that as you're handing over your geek card, balancing things out. That sounds great. I mean, the Russians attempted to send a mission to Phobos, and that didn't work out so well.
Yeah. Well, this wouldn't be till the 2030s. So it's quite a ways off. It's in the pre-planning stages. The technology that we would use for this mission is still under construction. So once that's done, once that's constructed, then we could really start looking at using it for deeper space missions to get to Mars. Once we've already tested it as far as the ISS and all of that more closer.
Right. And you better
fail. The Russians didn't fail in trying to get to Phobos. They failed trying to get out of Earth orbit.
Yeah, the frigate stage failed them.
And so the technology failure there had nothing to do with whether or not we can go to Phobos. It has to do with whether you build your spacecraft in the right order.
And of course, you've got to work quickly because Phobos has only got about 10 million years left before it crashes into the surface of Mars. So that's you're on the clock.
They need to get on that.
Yeah. So I mean, would operating out of Phobos give some kind of fuel savings, a way to be able to explore the surface of Mars without having that it would be cheaper to get to Phobos and dock there than trying to sort of do a landing and come back up?
Yeah, and then also because what NASA's looking at, and actually Buzz Aldrin was part of these talks a number of years ago, and what NASA as a whole seems to be really moving towards is thinking about this as a series of missions. So we think about Mars 1, it's a one-off. We're going to Mars and we're there for the long haul. That's not really how NASA's looking at this. It's a series of missions to sort of establish potentially long-term colonies, to get down to Mars, back to Phobos, to conduct different tests, and ultimately retrieve our people. So we're not going to be going there and leaving anyone long-term. People could come and go. So it's really looking at more of a series, a network of events that has long-term sustainability, that's not just a one-off, put all of our eggs in one basket type thing.
Awesome. All right. Dave Dickinson, you've got, I think it's almost a scoop, a really cool image of Europa occulting Io.
Yeah, every once in a while I see a story that goes around the internet that's not really making a big splash, but is really kind of cool. And this comes from the Large Binocular Telescope out in Arizona that's just been producing some pretty amazing stuff recently. See if I can cue this up. Right now, we're in the middle of a season of mutual occultations of Jupiter's moons that happens about every 5 years or so. So you have the moons passing in front of each other back and forth. Now, I think this should be running. Yeah.
Yep, this is working.
What you're seeing right there is a short animation of the body in front of that is Europa, and behind that is Io. And what it is that is initially when I looked at this image and I saw it, I thought the shadow was passing in front and doing kind of an annular occultation. But somebody straightened me out when I researched this a little bit. That is actually the body of Europa, and the reason it appears dark where Io appears light in the background is this is in near infrared, and Io is much brighter. And you can.
Are those the volcanoes?
Yes, you're actually getting.
Man.
I think it's
that's amazing.
I think that's Loki Pantera in the background. That bright spot there that's just off the center. So this is the kind of resolution they're getting with the Large Binocular Telescope is two 8.4 meter mirrors that are operating in tandem using interferometry, and they actually get the resolution of one big 22 meter mirror there. I mean, you're looking at something about an arc second across, not even an arc second across. If you ever looked at Jupiter's moons through a telescope, they just appear as star-like dots. And they're doing this kind of, not only can they get some kind of detail and actually see some kind of activity going on there, but they're able to do some direct imaging with exoplanets now and being able to get like the dusty disks around some of the stars where there's like protoplanetary nebula forming and things like that. But it's this alone, knowing what they're imaging there, I mean, it looks blurry, but it's actually pretty cool.
And so that's pretty much the most powerful ground-based observatory that's out there, isn't it, right now?
Yeah,
The Large Binocular Telescope?
Not for long, but we've got the TMT and we've got the Large Synoptic Survey Telescope coming up. This is one of the first of the next generation of really giant ground-based telescopes. For years, it's been about a decade getting when I lived down in Arizona, they just got the first mirror commission, so we used to joke and call it the Large Ocular Telescope at the time because they didn't have the second mirror up and running yet. But it's
Now, would that event have been visible to anybody watching?
Yeah, I've
Europa,
seen.
Or I've seen your position on Earth.
Yeah, you can see those kind of mutual occultations for the last 6 months or so. We've had a series of them. I wrote an article last October when the mutual occultation season started, and I've seen some amateurs catch some pretty good images. The best ones to catch are shadow occultations, where you've got one moon. You know how usually you have a moon casting a black shadow back on Jupiter? A moon can actually pass through those shadows too, so one moon can kind of pass in front of and cast a shadow back on another one. It looks like that moon just kind of dims in brightness a little bit, but I've seen some pretty good videos done. And I ran some simulations of this, and something I didn't realize till I started researching that article last fall, you can actually see solar eclipses, something similar like what you see on Earth on the moons of Jupiter, like from, say, you can see Europa eclipse the sun from Callisto. So I think that's kind of nifty because I've always been told that, that the eclipses here that we have in this epoch in time and space on Earth, the moon happens to be just, about the right size to cover the sun, that's unique in the solar system. Turns out that's not necessarily the case. Now, I think it moves a little faster than our moon, so the eclipses would be like 10 or 20 seconds long, but you can actually see during these kind of mutual occultations, you can actually see total solar eclipses if you were on the surface of one of those moons.
Wow. Okay, so let's move on. Let's see, what have I got next? Oh, right, Brian Koberlein, water around a white dwarf.
Yeah, this is an interesting thing. It's a demonstration of water. We know that water is common, and we're finding it more and more places. And in this case, there was a team that was looking at a spectrum of a white dwarf. And a white dwarf is a remnant star. It's been compressed down to, something like the sun compressed down the size of the Earth. It's mostly things like carbon, and it's held up by electron pressure. So when you look at the spectrum, you wouldn't expect to see things like oxygen or iron or things like that, because they would have collapsed into the core of the star. And so they were looking at this particular white dwarf and found not only things like oxygen and iron and a couple of other elements, but they found a ratio of oxygen to hydrogen, which would indicate water in terms of something that has impacted or been broken up by the white dwarf. So they did a basic calculation based upon how many of these metals they found and the hydrogen to oxygen ratio, and they could do a calculation that basically this white dwarf had fragmented something basically the size of Ceres. And so if you then look at how much water, based on the strength of the line spectra, you would get that it would have been about 38% water. So it's evidence of something the size of Ceres that would be 38% water in another star system. What's interesting about this is we know that water is fairly common, and one of the ideas for Earth getting water is bombardments by comets or asteroids. And so since this is an old star system, it's a white dwarf, the star has lived its life, to still have large objects with water in them adds support to the idea that both primordial bombardments and continual bombardments could in fact put water on a close planet like Earth.
Well, one of the other thoughts as well is there's, once it's a white dwarf, it's still giving off heat, and it may very well still have the planets that orbited around it when it was a more sun-like star. And the fact that there's still water in the environment could mean that maybe the region is still habitable?
It's possible. I mean, if you had an Earth-like planet, and a red dwarf would basically kind of fry all the life off of Earth, including all the water. But when it goes back to a white dwarf, when it collapses from a red giant to a white dwarf, the orbits might be disrupted enough that they could move inward, for example. And if that's the case, then you might be in some type of habitable zone where you could have some form of life.
Yeah, that would be super cool. And it's also sort of surprising, I guess, that there's still stuff around that white dwarf that can still be smashed up and destroyed and consumed. You would have thought that all of that stuff would have been cleared out a long, long time ago. Yeah,
it does kind of raise up some interesting questions about how white dwarfs form in the terms of we know that they enter a red giant stage, and one of the questions is, when the sun ends a red giant, when it enters its red giant stage, is Earth still going to be around, or is it going to be thrown off? Is Mars still going to be around? And this would lead credence to the idea that maybe, in fact, the planets aren't going to be as disrupted as we might think.
All right, Morgan. Oh, go ahead, Jolene.
Oh, I was just going to say, except for poor Mercury, obviously.
Yeah, Mercury's probably done. Venus is probably done.
So Morgan, we talked about a couple of missions. We've got another surprising Mars mission from a sort of unusual place.
That's right. This one isn't just a proposal; it's actually in the bag to be created. And this is a Mars mission called Hope that's going to be launched by the United Arab Emirates. And so they're targeting a launch in the year 2020 to arrive at Mars in 2021, around the time of the 50th anniversary of their independence from the British Empire. And the goal with the Hope spacecraft is to study Mars's climate on the global scale. And so what's unique about this spacecraft is its orbit. It's going to orbit extremely far away from Mars. At its closest, it's going to get about 20,000 kilometers away from Mars, and at its farthest, it's going to get around 40,000 kilometers away. And just to kind of put that into context, the farthest spacecraft that orbits Mars right now is the MAVEN spacecraft, and its farthest point away is just about 6,000 kilometers. And so we're talking about almost a factor of 10 further out. And what this is going to allow Hope to do is see the entire planet for its suite of 3 primary instruments, which is going to be a visible camera, an infrared, and an ultraviolet spectrometer. And what these will do is allow them to measure the composition and the changes of the atmosphere as dust storms and other weather-related events occur on Mars. But beyond the scientific aspects of HOPE is the fact that this is a new country that's for the first time going to be launching a space probe out there, and not just to orbit the Earth or to go to the moon, but to go all the way out to Mars. And the UAE is adamant that this is going to be done in-house. But they have partnered with a few American institutions to provide both scientific and technical support. And the lead institution here in the United States is actually where I work, the Laboratory for Atmospheric and Space Physics here at the University of Colorado. And they're the ones currently in charge of MAVEN. And so I would expect to see a lot of continuity and a lot of overlap between the efforts that MAVEN is carrying out today and will continue to carry out for hopefully the coming few years, and then the transition over to the work being done on the HOPE spacecraft, as well as the University of Colorado, the University of California at Berkeley, and Arizona State University have also been engaged as scientific partners for this mission.
It's great to see other countries and places around the world getting more and more involved in just pure science, right? As opposed to, I mean, the Chinese are pushing humans into space, and it's clearly they're setting off this second space race between the Americans, the Europeans, or the Russians, whoever's still capable of sending humans into space. But with what India has done by sending the Mars orbiter mission to Mars, and now what they're doing, they're putting the science for it. It's great to see this.
Yeah, this is an ambitious mission for them. Unlike India, which first launched Earth orbiting satellites and then participated in a lunar orbiting satellite, the UAE is intending to go straight from no space program, which is what they had about a year ago, to Mars in the span of just 6 or 7 years. Now, they're not going to be building the rocket that launches the spacecraft. They haven't announced who they will be partnering with to do that, but I would say SpaceX is a good bet in this instance. But they are going to be doing as much of the engineering and as much of the actual fabrication as they can, if not actually within the borders of the UAE, using engineers and scientists who are citizens of the country.
Yeah. Yeah, that's fantastic. All right, so let's move on, because we got lots of news, but we got lots of people. So, Jolene, let's go to you next, and we're going to talk about I'm going to talk about the fact that the Milky Way and Andromeda might already be in the process of merging.
This week, Quark's quasars, and the headline was something on the lines of Milky Way galaxy and the Andromeda galaxy might already be merging. They might already be in contact. So we know that there's going to be a collision. We discovered this years ago. The Andromeda, currently 2.5 years away, are going to merge into one galaxy. And, well, we might pass through a couple of times, but anyway, we're going to have interactions about 4 billion years. However,
sorry, Jolene, I think we're getting some you're Cyloning on us here. So there's something going on with your upstream connection, and for once, it's not my fault.
It's not my fault.
Yeah, can you try turning down your bandwidth? Do you know how to do that? So try turning down your bandwidth a notch so that you'll get more pixelated, but your sound should be a little better.
I don't know how to do that.
At the top it says adjust bandwidth usage, and there's like a little triangle, and you can turn that down. Right, it'll be on auto right now. You can turn that down. See, watch me. Yeah, I am super pixelated. Let's play Minecraft with Fraser. No, it's still happening.
I don't know what the thing is.
Well, we'll move on, and I will help you with through text, and then we'll come back around and see if we can take another crack at that story. So, Dave Dickinson, let's take a look at Saturn.
Yeah, we're actually approaching the time of year where Saturn is coming up to opposition, which means it's going to be rising. It's going to be joining the prime time lineup of planets and rising when the sun sets. I was just out at the final star party of the school season last Saturday, and Saturn was the star of the show. We actually had all the naked eye planets except for Mars, which is on the other side of the sun right now, going towards solar conjunction next month. We have Mercury, we have Venus, we have Jupiter high up in the sky, and Saturn is just joining in right now. And what's kind of interesting is as we're going toward 2017, the tilt of the rings is widening from our perspective right now. It can widen out to about, you remember back in 2009, we had them edge on. And about every 14, 15 years, they come back to the same edge on point. In those in-between years, it comes to a wider point where we're entering into that right now. A photo actually from Andrew Symes. Let's see if I can share this without.
Yeah, it's such a bummer when you really can't see the rings of Saturn, right? That you get like so here's they're on edge on. I'm sharing it, and then over time you get the spring where you can really see the rings sort of at a nice big angle. Yeah, and there's your image there.
Yeah, this is from Andrew Symes up in Canada, failed protostar on Twitter. And he shoots these with an iPhone through his telescope, which makes it all that much cooler.
Yeah, you did an article about Andrew's work on astrophotography, astrophonography.
Yeah, it's amazing what he's doing with just doing image stacking and afocally aiming his iPhone up through his, I think he's got a 5-inch telescope, Celestron. But you can see how the rings are changing from our perspective right now, and they're actually getting to a wider point. So it's really Saturn is getting at its most photogenic right now, where you're getting that wider point. And you can see the moons in a small telescope too. You can see Titan. You can see with a larger scope, you can see Mimas and Enceladus. About 5 or 6 of the smaller moons if you look in there close. They look like little dots, but it's kind of cool to actually watch them there. But it's you can see that he's actually getting the Cassini division and a few other bits of detail in there. Yeah. So yeah, this is the time to get out and watch Saturn right now if you can. It's rising about 9 or 10 o'clock. You've got it down in the southeast if you're up in the northern hemisphere here. So it's going to be best around midnight when it's high down to the south. It's unfortunately it's got a little bit of southern declination to it right now for the next few years, so it's not riding high up in the sky for people up in North America. But still, it's always anytime I'm out, I always take a look at Saturn. It's always cool to see.
Is Saturn arriving earlier or later each year? I'm just trying to think about each year. We always have Saturn in the spring, and we always have Jupiter in the fall.
It's moving
for now, but
because its oppositions are moving toward. I want to say they're. I got to think. Oppositions are moving earlier, I believe. I'm pretty sure I'm right on that. As far as the period is not quite 365 days because Saturn moves a little bit. Saturn orbits once every 30 years. It's ironic, when Saturn was in the constellation Virgo a few years ago, I realized, you know what? When I was a young teenager and I got my first telescope, it was in Virgo then too. So I've been in astronomy for one Saturn year.
One Saturn year. That's awesome. Because hold on. So I remember seeing when I was a kid, Saturn was low on the horizon in the summertime. But again, that was probably one Saturn year.
Yeah. It probably was in the same because it's going to be south of the celestial equator now for quite some time.
Yeah.
Okay. I had it reversed. The synodic period is 378 days, so that is 13. I consulted my almanac here. It's that's 13 days past one Earth year, so it's moving slowly it's moving later each year. So it's going to be moving May into June into July over the next few years. Opposition.
Right, okay. So just a little information here. Yov Landsman notes that the Soviets failed at less than 1 kilometer from landing on Phobos with Phobos 2 in the 1980s. So they've failed Phobos. Phobos has failed them too many times.
Russia and Mars just don't get along.
I think they're like 14 for 0 now.
Yeah, they've just sent a hail of destroyed spacecraft at Mars.
But they've landed on Venus, and America's never done that. So.
Yeah, a lot of times. Tom Nathy asks about the white dwarf story, Brian. Could water, as vapor, molecules, or ice, condense back on the planets during when the star drops into its white dwarf phase?
It could. I mean, you could certainly, if the temperature drops, you could get, if there's water vapor around, it could condense back to the planets. The interesting thing is that it wasn't cast off by the red giant during its active period. So it wasn't boiled off.
Yeah. Cecil Morgan asks, and this one's for you, Sandy, what is the point of putting a propulsion system on VAMP?
What is so there's probably atmospheric drag at that level, so you have to keep it upright. You have to keep it flying. So I guess there's ideas of having balloons on Venus that would keep themselves upright, but if you want to keep flying and study other aspects of the atmosphere, maybe there's stuff on the night side versus the day side you want to see. Give it something, maybe a range of latitudes. There's a lot of reasons that you might want to be able to move rather than just sort of float aimlessly like a jellyfish.
What do you think about the pictures that you see of this, where you've got like these really nice, fluffy sulfuric death clouds, and you're sort of flying your little dirigible with your steampunk hat through these clouds? Would you actually see it, or would you just see this awful hazy mist everywhere? Oh, you're muted again.
I guess it also depends on where you are in the atmosphere, what's going on at 40 kilometers. Let me see if I can...
I guess that was unfair.
Certainly, like if you were on Titan, you would be seeing clouds at those levels and higher because you're beyond the point in the atmosphere where clouds form. Hold on one second.
I guess you'd have to figure how much vertical convection there is that would make those kind of cumulus. I don't know.
Because, I mean, when you see the pictures from the surface of Venus, I mean, there is light getting through all the way down through all that
So
clouds.
you have sulfuric acid cloud layers at 50 kilometers and above. So you do have condensance at that level, and it's above the sulfuric acid haze. So, and the pressure is similar to Earth's pressure at that level. So you probably would see clouds. I just don't know what sulfuric acid clouds look like. Would they be those fluffy cumulus clouds, or would it be something more like today in Tucson where it's kind of overcast and
yeah. Let's see.
So there's also a hazy layer above that of sulfuric acid drops. So yeah, so it's all sulfuric acid. I don't know. Don't count me in for going along on this mission.
No? All right.
Do not want.
So Yovlansman also asks, what is the albedo of the white spots on Ceres? So do we know what the albedo is of those, Morgan?
I don't know if we do. In order to, you could certainly make some estimates, and I'm sure that the science team has an estimate based on that, because you know the same amount of light is hitting those white spots as is hitting all the dark terrain around it. And so by measuring the ratio of how much light reflects back from the dark area and how much light reflects back from the bright area, you could come up with kind of a back-of-the-envelope way of measuring the albedo. Now the trick is, now these sensors basically can't absorb infinite light coming in. And so there's usually a level of how much light per second they can measure. And if you hit the top of that, then you can't know the albedo. You could know some lower limit for it, but when your sensor reads max, you don't know how high max is. And that's the trouble. So as far as I'm aware, they haven't announced any albedo, but I'm sure that they have one working in their minds. And the closer we get, the more accurately we'll be able to measure that.
Right. Okay, cool. And let's see, Jolene, how's your connection doing? We're going to test out and see if turning down the bandwidth helped.
I did actually figure out how to turn the bandwidth down, so small victories there. Are we working?
Yeah, you're working. We can hear you just fine. You are definitely pixelated beyond comprehension, but we can definitely hear you fine.
All right.
Oh, I spoke too soon.
Oh, no, we're gone again.
You're gone again. As long as you don't talk, it works fine. And then as soon as you start talking,
Just if I stay really, really still and very low, can you hear me?
Yes.
Yeah, don't move.
Okay, I won't move. All right. So Andromeda is going to hit the Milky Way in about 4 billion years. And scientists recently discovered that there's enormous halos that surround most galaxies. And these are created by supersized, which when they go off, blast a whole bunch of heavy elements into the surrounding galaxy. 1,000 times more massive.
No, I'm so sorry. No, it's just Please don't begin the robot apocalypse. That's all I ask. All right.
Dude, he's Canadian, and he said so sorry. Dude.
So sorry. Yeah, my girlfriend gives me a hard time about that all the time. She's American and just yeah. Yeah, we'll help you try and diagnose this. So stick around until after we shut down the Hangout, Jolene, and we'll try and diagnose this so that it never causes you a problem again. Okay, so we're sort of still got a little bit more time. So and you had so many good stories about solar roadways and stuff that's happening with Mars 1, but we'll have to hold on to it maybe for next week. Dave Dickinson, I'm going to give you the last word this week, and that is about a crazy blue sunset on Mars.
Yeah, it's kind of interesting that Curiosity, Planetary Society, put out some images and sequences recently that were taken from the Curiosity rover, showing that, ironically, although we have blue sunsets here, or red sunsets on a blue planet here, a red planet apparently has blue sunsets, and it's actually kind of cool to watch these. You know, we've seen this before from Spirit and Opportunity, but we've got the images pretty high res from Curiosity now. That and what you're seeing is basically there's a differential in the amount of the size of the dust particles that are suspended up in the atmosphere, and it's refracting and filtering out that blue light, kind of like Rayleigh scattering you get here in the Earth, where you get the blue sky, except for they get it when it's down, the sun's down at that low angle on the horizon. You're looking through a thicker section of the atmosphere, where we tend to get that scattered out, and we only get red here when we get the sunset. So I just think it's kind of ironic. I don't have the video queued up, unfortunately, but it's kind of cool if you search around Curiosity blue sunset. It's been going around the news recently. Again, it's not really new because we've seen this from Spirit and Opportunity before, but it's just kind of neat. Hopefully humans will get to see this pretty soon here in a couple decades.
When we've destroyed so much of our atmosphere that all we can experience are blue sunsets?
Yeah, hopefully when we're on Mars.
Yeah, exactly. Okay, well, did anyone have anything else that we want to talk about? Let's dig a little bit into what some of the stories.
The ISS rotation got pushed back. That was still kind of speculative this week because of Progress, basically because of the Progress failure.
Right, so can you give people just a little more information on that?
What we know right now is they're pushing back the astronaut rotation for the next expedition. So ironically, although the supply ship didn't get there, the astronauts that were to come home this week are staying up there for a few more weeks, partially because they want to investigate what they're not quite still sure why the Progress failure happened. And also, singer Sarah Brightman, that was going to go up there as a space tourist, for reasons unknown, she canceled her trip. It's not known if she canceled it for a personal reason or if the Progress failures in the crew rotation and bumping everybody back is related. There was speculation that a Japanese astronaut, because he made a journey to Baikonur this week, that he was going to take that slot next month on the next rotation. However, it turns out he's only there for training, so there's actually an empty seat up for grabs right now to go up for the next expedition.
Yeah, one of the cool things about the delay is that one of the female astronauts aboard the space station right now is likely to set the all-time space endurance record for women aboard the space station. And so that extra month will put her over the limit. I can't remember her last name. Her first name's Samantha, because she goes as Astro Samantha on Twitter, which is all I know. And she's likely to break the record now if it does indeed get delayed by a month.
So I'm gonna share one story from the so a lot of the stories that we talked about today were suggested by the Weekly Space Hangout crew, and this is of course the Google Plus community, WSH crew, that just does an amazing job of really being the executive producers of this show, and we really couldn't do the show without you, both in terms of helping to figure out which guests you want to see and scheduling them, but also just sort of showing us which stories you want us to talk about. And I know that this week some of the stories that were presented were actually, we took a look through and saw what cool stories were in there, and we were able to present them. So again, we really appreciate your help. One story, and this was presented by Matt Woods, is that there's a crowdfunded campaign on Indiegogo to help defend the Earth against asteroid threats, and so they're looking to raise $200,000 US to nuke asteroids. So what do you think? Do you think I would love to hear some of your opinions here. I'm going to give Sonia, I'm going to give you a chance to talk about this. Do you think that nuking asteroids, or I guess crowdfunding the defense of the Earth, is the way to go?
Where are they going to get a nuke for 200K?
Russia, where do you get anything for that?
Yeah, exactly.
Can you order that off of Alibaba?
Yeah, I think you can order it, or at least high speed centrifuges if you need to.
There was an article that Matthew Francis wrote about this, and it's a bad idea.
It's a bad idea to nuke asteroids, or it's a bad idea.
It's a bad idea to nuke asteroids.
But what do you think about the crowdfunding the defense of?
Who's running this?
It's go ahead and look it up. Crowdfund asteroid
Indiegogo?
defense. EADP. Yeah.
Indiegogo. Is this like against the terms of service of Indiegogo or something?
That you're not allowed to defend humanity from an existential threat? No, I think that's all right.
Sorry. So if I have the headset on my ear, I've got this at the lowest volume right now.
Am I still too loud?
Everyone's still too loud. Okay, what are they doing? Come on. So this is some dude in Copenhagen who's like, we're going to defend the Earth against asteroids.
Yeah. So I just thought.
Okay, hypervelocity asteroid impact vehicle. This is a great idea. So part of the problem is that you kind of want sort of a universal, or at least a global body deciding what to do about asteroid impacts. So let's say that there's an asteroid that's on a collision course with Paris, right? And that this group that's calling themselves, I don't even know what they're calling themselves.
EADP?
So let's say EADP decides they're going to deflect this asteroid on their own, and they're going to deflect it from Paris, and it's going to land in the Atlantic, except they screw up. Instead of deflecting from Paris, it's now going to hit St. Petersburg, right? Like, who takes responsibility for this? Like,
the asteroid.
Get really mad. Well, the asteroid is an inanimate rock. The asteroid doesn't have feelings or intentions. So, yeah, I just don't know. Who so one group's going to take responsibility for this. What happens if it goes wrong? And I think the money should be much better spent on space telescopes or early detection, and there are groups that meet to discuss this. I am a part of the International Asteroid Warning Network. I think we even have a website these days, and it's an international group of people, including folks from the insurance agency, and it's started by the UN to sit down and try to figure this out. And I'm all for people supporting this, but it would be good if they were willing to work with international partners on this rather than just sort of cowboying it on their own.
If you want to back a space Kickstarter this week, then the Planetary Society is running a much more plausible one to help fund their light sail, and that's going to test in the coming years the idea of using sunlight as a way to power spacecraft. And I believe they've reached their Kickstarter goal, but they had some pretty cool rewards if you're interested in backing actual space research on Kickstarter or other crowdfunding.
So their FAQ, how will you get nuclear explosives? We will not. The Emergency Asteroid Defense Project will develop and build the vehicle that transports the device to provide a sustainable solution for protecting Earth from imminent asteroid threat. A nuclear missile would not be able to deflect an incoming asteroid by itself. We will not arm the HAIV, nor will we execute the mission. So what are you guys doing?
They're going to build the spacecraft that's going to do the defending.
Right, but they said they will not execute the mission, so I don't know what they're...
They'll be ready, and then when the asteroid is detected, when the asteroid is detected, the president will get on the phone and like, what can we do to defend against? We've got one choice. We've got one option. It's a long shot. You remember that Kickstarter?
This sounds even more cowboy than Bruce Willis in Deep Impact.
I'd be more comfortable if we just called Bruce Willis. Honestly, I feel like.
Yeah, I think you guys have a lack of imagination, and you're just tied by the bureaucracy of the old way of doing things, of like having meetings and nothing getting accomplished, and yet every day asteroids are buzzing past the Earth and nobody's doing anything about it. So the crowd is coming together, and they're going to raise the money, and they're going to protect us. And the politicians can...
I don't want to be protected by these guys.
Oh, so mean.
I can see
I have hope. I'm on board.
I'm glad someone's optimistic.
Yeah. Okay. Well, let's start to wrap things up. So as I mentioned just briefly, there's the WSH crew, which is the community on Google+, and I really recommend it if you are a fan of the show, that you go join them. And one of the reasons actually is I got a question from Pete Brumwell, who I hope is still watching right now. Fraser, you're quite active on Twitter. Would it be possible if earlier in the day you could post when the WSH is due to start, or post a warning a few hours prior, and then would be able to catch more of your fantastic episodes live? So I appreciate that, but I just can't because I got a million things I'm doing. So, but the best thing to do is you go and where we have the event every week, and if you say yes, you will attend, then it'll get put into your Google Calendar. You'll get email warnings that it's going to be happening. You'll get great recommendations. And if you want to be reminded about when we've created the event, then join the WSH crew, because they will post every week when we post the new event. They'll do a reminder there. So if you join the WSH crew, you will get all kinds of reminders that the Space Hangout is going to be happening. Or it always happens at noon on Friday, Pacific time. So there's that. But go ahead and join the community. But one thing that I wanted to just sort of pick everyone's collective brains about is that, as you know, in addition to this, we also do a series of very sarcastic space videos twice a week. And I would love to get your feedback or your questions. What would you like us to answer? What would you like us to dig in more deeper? What things would you like us to both research and be very snarky about? So maybe if you want to post some of those ideas in the WSH crew, some of your topics, then we'll kind of dig through and maybe pluck some of those out and start doing some videos. So let us know. Okay, so let's wrap this up. So let's give people a chance to shamelessly self-promote themselves. Sandy, where do people find out more about you and the projects you're working on?
I am on Twitter at Sandy, and Morgan and I are going to be going to a workshop in a couple of weeks to learn about new media in the context of the Maven mission. So you might even get us goofing off together in person.
That's great. And are they going to be pulling from your now vast level of knowledge in all forms of media?
I don't know, but they're going to be teaching us about Mars and my philosophy as well. If you can't beat them, at least get them to pay for you to learn about Mars.
Brian Koberlein, where can we find out more?
You can find me on Twitter at Brian Koberlein, or you can find me at my website, which is briankoberlein.com, and I've got daily posts about astronomy and astrophysics, and a weekly podcast. And if you want to support it, you can go to Patreon/Brian Koberlein, which they always laugh about because I have to hawk this, and you can support me.
I love the fact that you now, through sheer fear, will mention your Patreon campaign so that I don't have to force you to do it. So that's terrific, Brian. There you go to patreon.com/Brian Koberlein.
Yes.
And you can support what Brian's doing. And seriously, he's creating so much space news. You really have to get on top of this. Dave Dickinson, where do we find out more?
This week I was active on Sen, Universe Today, and Listosaur, and I put up free chapters of my science fiction on Astro Guys with a Z every week. So there's free chapters up there. Go ahead and read them, review them, tell me what you like. Tell me what you don't like. That's what writers really want to know. So, okay.
And so you're waiting for all these chapters to get picked up and turned into a book and then into a major movie directed by.
Exactly. It worked for Andy Weir to just give his stuff away for free, so I was like, why not? I'm going to try that too. Myself.
Yeah, exactly. It's just a matter until Ridley Scott works on your project. So, but if I wanted to buy a Dave Dickinson book, I could do such a thing, right?
Yes, there's an author page on Amazon. It all links back from the free chapters. If you want to read the stories in total, you can go right through my website and pick up the Amazon stories for 99 cents as well.
So I can go to Amazon.com and I can purchase books that you wrote, and you will get some of the proceeds of that money. Is that correct? I get what's more like a stipend. I wouldn't call it approaching. Work with me, David. I'm trying to promote your stuff here to wait for you to get some money.
Sure.
All right. let's move on. Jolene, where can people find out more?
If you can hear me, you can find me on Twitter at Jolene723, I think. And also from Quarks to Quasars, my handy-dandy little science website that I run, where we post science news and information and so on.
And so if a person wanted to support the work that you were doing, they should go to From Quarks to Quasars and read and enjoy your stories, and at the same time enjoy all of the generous sponsorship that surrounds it.
Yes, and we do have a Patreon as well that we started just a couple months ago because we are starting to do videos, but of course all the equipment is relatively expensive, and also infographics, so Photoshop, that stuff. So we do have Patreon as well, but all that stuff can be found at the website. We have links to everything. So.
Okay, great, and just from quarkstoquasars.com. Fantastic. All right, Morgan, where do we find out more?
Well, as always, you can find me right after this show over on the Google Plus Space community. Just go to plus.google.com, click Communities, and choose Space. I'll take any of the questions that we didn't get a chance to answer over the course of this week. You can find the second installment of my now weekly Cassini mission updates on CEN. That's cen.com. And you can follow me on Twitter at Morgan Rehnberg or visit my website, morganrehnberg.com.
Awesome. So you should go to CEN, you should read Morgan's article, and you should appreciate it so that he can get perhaps, so that column will
Tweet
continue.
at Charles how awesome I am. And,
yeah, tell Charles that you thought it was great that Morgan is doing these articles, and that way he can continue getting more writing work. So that's fantastic. All right, of course, I'm Fraser Cain, FCain on Twitter. Subscribe to this YouTube channel if you haven't already, but I don't know why you wouldn't. And we really appreciate it. Of course, my website is Universe Today. Come and check it out. So thanks. Oh, and patreon.com/Universe Today, obviously. So thanks, everybody, for joining us for the Weekly Space Hangout. Thanks for all of your support so far, and we will see you all next week.